Good morning, friends. Already we have completed current electricity and now we are moving to the next chapter. It is moving charges and magnetism. Moving charges and magnetism. See, electricity and magnetism, these were the branches of physics people studied since last 2000 years. Electricity and magnetism was known for 2000 years, but the intimate relation between them was found 200 years ago. That is, somewhere in 1820, that one, the Danish physicist Overstein, in his one lecture demonstration, found that when the magnetic needle is placed near current carrying wire, it shows deflection. This is the magnetic needle. If it is kept near current carrying wire, it shows deflection. This simple observation made him to conclude that the currents or moving charges produce magnetic field. Now, this was the observation which was made by Danish scientist Overstein. Now, let's see what he studied thereafter. Suppose that this is the wire and this is the magnetic needle placed there. Then the battery is connected. There is the plug key. Key is closed, current will flow through the wire. This magnetic needle is showing deflection. If this key is open, no current flows through that one, it will not show deflection. So without current, no deflection. First one, there. Current, it's a deflected. When current is passing, it's a deflected. Now, what he has done, he has reversed the direction of current. This battery, whatever battery was connected, its direction of current was reversed. Current is going in this direction. Reverse direction, when the direction of current was reversed, then there was a reversal in deflection of magnetic needle also. So, whenever current was reversed, magnetic needle also deflected in opposite direction. Magnetic needle deflection was also reversed. This is first point. So, the direction of deflection of magnetic needle is decided by the direction of flow of current. Then, he increased current by keeping magnetic needle fixed. When the amount of current increased, the magnetic needle showed more deflection. So, the current, increase in current increased deflection of magnetic needle. Next one, what he has done, he has changed distance of the magnetic needle. When magnetic needle was kept away from the current carrying wire, then in this case, he found that this deflection was reduced. So, as the magnetic needle is taken away from wire, for the same amount of current, deflection was also decreasing. Similar way, as we bring needle closer to the current carrying wire, deflection increased. So, magnetic deflection or magnetic field which is created by this current carrying element is decided by two things. One is amount of current and the distance at which the needle is placed. So these are certain observations he made by doing some experiments. Another thing, when the iron filings were just sprinkled around in this one, then they were arranged in circular fashion. Iron filings, they were arranged in concentric circles in such a way that the wire is at the center of all these circles and perpendicular to their plane. So, current carrying wire and magnetic field produced, they are perpendicular to each other. They are circular magnetic field, which is a circular. It is just figure is given in book. If you see this orientation of needle, it becomes along the circular path. But another thing, this wire is perpendicular to these circles and at the center of those circles. So these were certain observations this Danish physicist Oversteed made, and then he also now and specifically we are going to study these topics that includes Wyatt and Savart law, Ampere circuital law, current carrying parallel conductors and forces between them, then the coil in the magnetic field and galvanometer. Galvanometer as an ammeter and galvanometer as a voltmeter. These are the topics in this chapter. But hereafter, whenever we are studying magnetic field, the convention is decided. It is, if it is a dot, circle and dot, it indicates that the field is coming out of the plane of paper. Dot coming out. If it is a cross, it means that it is going in the plane of paper. And this remains same throughout the textbook. These are important things. Circle and dot indicates that the magnetic field is out of the plane of paper. Circle and cross indicates that the magnetic field is in the plane of paper. That's all for this introductory topic. Thank you.